Hi, Andre Dan. So your question was about the output current waveform for a flyback converter. I tried to illustrate it like this. This was our topology that we also have seen in our lecture. So my input voltage, if the switch is on, the whole input voltage is across our magnetizing inductance and primary side of our inductance. And please notice that the dots are 180 degrees phase shifted. Means that if I have here plus and here minus, that would mean here I have plus and here minus. So, if the switch is on, the input current flows like this. And if I assume that I operate this flyback converter in CCM mode, continuous conduction mode, and minimum current on the magnetizing inductance increases, as we know, di over dt, and at the same time the input current waveform has the same waveform as magnetizing inductance. This is also E minimum and E maximum. And on the secondary side, I have no current. If I switch on, actually this is plus, this would minus, and this will be plus and minus. That means current cannot flow in this direction because of diode. During switch on time, I have zero current on the secondary side. But the output voltage, as seen here, is the voltage of the cap. That means V out is equal to our capacitor voltage. And the secondary voltage here, as we know, the primary voltage divided by turns ratio of the primary side should equal to minus, because they have 180 degrees phase shifted. According to, for example, this reference point. If I have here plus and this should be minus, and secondary side of the voltage divided by secondary side turns ratio. And if I rearrange it again, the primary side voltage is equal to output voltage is equal to C out, and it should be also equal to, I just wrote here output voltage instead of V2, because I assume that the diode has no voltage drop. So the primary side voltage is equal to the output voltage times the turns ratio. And what happens here, the diode during the switch on time doesn't conduct. That means my load is only supplied by my capacitor. And I assume that it's a continuous conduction mode and in steady state. That means this should be in steady state, and in steady state this portion of current I see it is minus. That would mean my output current is supplied from the cap, and it's a constant current. We know that if we use DC-DC converters, it's not important in buck boost, flyback, two switch, forward two switch. I have always a constant current at the output side with a little bit ripple because of the cap. If the cap is big enough, it would mean my output current, E out, should be constant. And what happens here when the switch is off, this magnetizing current cannot flow over the switch because there is also a diode here. It should recharge over my primary inductance. It goes down, and at this time the input current falls to zero because no current will flow from my input source in one period, and it should, for the second period of excuse me, this would be the second period switch time, and now during the off time, this is off, this is on. During the off time, I will have now here plus, would mean that here should be also plus, and minus is here, and the current flows. If the current goes into the dot on the primary side, the current on the secondary side would come out from the dot. And this current, what I see here, is exactly the same current this minimum current also is seen here. Now, what is the difference between diode current and capacitor? Because output is always either on time, at on time, or on off time. At off time, the current should be constant and positive. The current is always positive. And how is it possible? I have a constant current during the on time here. It comes from this current is coming from my output cap, and during off time this current comes from secondary side. The ripple, AC ripple portion flows into cap. This current comes from diode, and please pay attention that this portion minimum current is not equal to that current. It's not equal, because if I push this current down here, for example, this amplitude should be equal to this amplitude, and then I would say this amplitude is smaller than, let's say, x epsilon. The amplitude of x is always greater than amplitude of y. And the cap is charged during on time and discharged during off time. But the load is always charged during on time or off time. And that's the trick. If you take the integral of this voltage is input voltage during on time and input voltage across the secondary side of the primary transformer should be always equal to each other. That's the formula how we calculate the duty cycle. Flyback converter is derived from buck boost converter, and the current waveform, or you can also put these current waveforms here instead of IC, and you can find out the output voltage. We can also write it like this: I of C is equal to V out dt. And in order to get, for example, such kind of current waveforms, let's say during on time, it's like that. This portion, the integral of a constant is 0, and there is no change at the output. The output has also a constant voltage. And here, the AC portion is taken from the cap during off time, and the constant voltage waveform, it is that. This would be V out. That means this will be output voltage, actually the average of output voltage, dt t, and let's say the current of the IC. Now I will show the current waveform of IC. This will be No, the output voltage, it was just shifting this waveform to the down. That would mean this should be equal to X, that portion, and this should be equal to V out divided by, if we want to show this current IC and V out, this would be V out divided by resistance. So I hope I could give an answer to your question.